Hi guys, good morning everyone. So today we're discussing about dynamic provisioner, and for dynamic provisioning we selected NFS. So we created an external NFS server. From there we created one NFS share, and that share, by using that share, we deployed a NFS client provisioner pod inside the cluster so that it can become the gateway, so that this NFS client provisioner can become the gateway for the pods which required PVC or PV, and we created yesterday PVC and automatically PV got created. So now one thing is left inside this. We need to create a uh, pod, and I'm going to use that pod. Okay, I'm going to use that volume inside that pod, the PVC whatever I created, so that we can able to access this PVCs to the pods. Okay, so let me log into it. It's logged into the master server. So yesterday we executed these YAML files. So one is for NFS deployment, so that it deployed NFS client provisioner, and also class storage class we created, role-based authentication, access control we created, and finally when we executed this one NFS, so kubectl get PVC. So this is a one. Okay, PVC got created. So how it got created? Automatically it got created, and the physical volume automatically got it created. Get PV. So this is the one. Okay, and it's using this one. So now this PVC we can give it to any of the pod. So we need to give this name. So what I'm going to do? mm, okay, so I'll copy this busybox YAML file to the NFS provisional directory. Again, I'll go back to that. So here I copied this file busybox, so that I will create a pod with this YAML file. So busybox is one of the type of image. Okay, so like Nginx, why we are using Nginx. So busybox is an image, so we can create a pod with that. So open this, and here the volume name, it's up to you what are the volume name you want to give, you can give inside that. And this is a persistent volume claim. So here I need to use the persistent volume claim, change the name. So what was the name it got created in the PVC? PVC hyphen NFS hyphen PV1. So this is the name, PVC NFS hyphen, what was that after NFS? PV1. Okay, this is the name, persistent volume. And inside that uh, container, This volume will be mounted as a mount path slash data, and this is the volume name. Okay, so means persistent volume, we are using it as a volume for this container, and directly persistent volume cannot be mounted, so we need to tell that okay, this is a volume and this is a volume name. You can give any name, and this volume we are getting it from the PVC, and this volume we are mounting inside the container. Okay, so we are telling the container that this is a volume, and mount it on the slash my data so that it can be mounted. Now kubectl, let me check, get pods, already busy box is there which we created, delete. But our NFS client provisioner is showing in error state, means the NFS server is not online. Um, I think this is not the one. Which one we used yesterday for NFS?
You use Docker server, I guess.
No, Docker doesn't have enough space, so I selected some other server. Which one? Is it Nexus server or what? I deleted Nexus server. Oh, so let me check. 48.251, which IP it is? This is not the one. I think I deleted that mission. I think I used this one Nexus server. Just now before starting the session, I deleted these unnecessary servers. Um, Again, I need to create NFS server, and I need to is it okay? Instead of doing all these things, it's very simple. As I said, just we can create the pod, and this pod can able to use this volume. That's it. Okay. So again, if I need to, unnecessary time will be wasted. Create an FS server, again redeploy this, all these things. Instead of that, only the pending is how the pod is going to use that PVC. So that is same how we practiced previously. So we change the file here. So here, what are the volume you created? That volume PVC you need to give inside this manifest file. That's it. So this is about the volumes. Okay. So now we talk about the real thing. Okay. Till now we were discussing about the components or objects of the Kubernetes, like what is pod, what is network in the Kubernetes, and different resources like how we deploy the applications that called deployment and stateful set, daemon set, and the services we discussed, load balancer, uh, and node port cluster IP. and some other objects like node selector, lot of different objects we discussed till now, and the important is the volumes, Kubernetes volumes. Okay, these are we are learning the objects, but if you are a DevOps engineer and in your organization and they decided to move the applications or we should migrate the applications to deploy on the Kubernetes cluster instead of virtual machines. Assume previously they were deploying it on the virtual machines. Now they decided to deploy it on the Kubernetes cluster. Then how you are going to deploy those applications, how it will work in the real time, that we'll discuss now. Okay, so now we individually discussed about each topic. Okay, but now whenever see the developers writing the code till now what was happening, so it is going to be code check-in is going to be done to the source code management, and this is a source code management, and from here whenever the check-in happens, what it will do, Jenkins will pick up the code, right, and Jenkins will clone the code and it will do build, right, it will do the build, and then it will copy that artifact var file inside the artifactory, whether it can be Nexus or whether it can be Artifactory or whether it can be any cloud environment like ACR, GCR or ECR. Okay, so here it is going to store. From here, by using this Artifactory, will deploy it to the some environment, virtual machine environment, whether it can be cloud environment or whether it can be on-premises environment. We can deploy this application over here, right? Now, when it decided to deploy it on the Kubernetes cluster. So how we are going to deploy? So here, whenever the developers are doing the code check-in, it is coming, Jenkins will pick up the code. So when it is deploying the applications on the, if we are trying to deploy it on the Kubernetes environment, so assume this is a virtual machines and this is a Kubernetes cluster. In case if you want to deploy here, then how the scenario will be. So obviously CI CD job is mandatory. CI jobs will be basically based upon the code check-in. Means whenever a developer modifies anything in the code and he push the code, he do commit, then immediately the CI job will be executed with the help of webhooks configuration. So that will be compulsory. Whenever the developer's code check-in done, then it is going to create a CI job, execute a CI job. So what contains a job? It's do integration. Assume this is a Java application. So if the Java application is there, then this Java application needs what? First of all, it needs Git to clone that, and Maven is a build tool, right? So what it will do, we will write Jenkins pipelines. So in the Jenkins pipeline, we'll have a stages. Stage one, clone the repository. This repository. Stage two, execute the Maven command to create an artifact. And third stage, push the artifact to artifactory. Okay, this will be stages will be available. And fourth stage, you can notify it in the Slack or you can intimate. Okay, that can be written inside this Jenkins files. If it is a freestyle project, you can configure, or else if it is a pipeline, you need to write a declarative pipeline script or scripted based pipeline. Okay, that you need to write it here. So if it should be deployed into the cluster, then there should be another step will be added, that is called as building the Docker image. Means in this CA job, so the stages will be what, clone, okay, and build artifact and create Docker image and then push the Docker image to Artifactory. So these are the 4 stages will be available. We need to create it. Okay, so because in Kubernetes you are going to deploy the Docker images only, right? We are deploying with the Docker images. So here prerequisite, what else you need to install here? Apart from Maven, you need to install Docker also inside this, because to execute the Docker command to create the image, you should have Docker installed inside this one, and so that it can able to create image. Means by using this artifact, it will create an image, and that image need to be pushed. So images are going to store here. So in the CD job no need to be automatically. Whenever we want to deploy it. So in the CD, what you are going to use? If you are deploying into the Kubernetes cluster, so what you are going to use this image. So where you are going to use this image? Basically, we are deploying some YAML files, right? Let's say nginx maybe app.yaml. So inside that kind is, let's say, deployment. Okay, means we are using deployment. Obviously, applications will be deployed with the type called deployment only. And here we'll have a container specifications, and inside that image will give this artifactory URL. Wherever this image is available, the image URL name tag means version, because whenever this image is getting created, multiple images will be stored here, right? Whenever the code check-in is done, it will execute this job and it will create an image and it will store here. So same way here, which image name you are going to provide, right? So this is a YAML file you are going to use. But you are not going to use only the single YAML file to deploy the application in the real time. That's why we have learned Helm charts. Okay, so we use Helm charts mandatory. You are going to use Helm chart because your single kind deployment is not going to work. It needs service, right? It needs service deployment.yaml file to deploy the application. It needs a service to access it from the external world, or maybe internally the cluster communication should be there. So you are going to use service.yaml, maybe it's a load balancer or maybe node port. And apart from this, this might require config maps compulsory for properties. So always you no need to uh, change the code level. So if anything you can want to change the properties of applications, you can do it from the config map. And secrets to maintain the secrets, and in real time you configure hpa.yaml file, horizontal pod autoscaler. Okay, so like this some resources. Guys, just give me a minute, I'll be back. Someone is knocking the door.
This conference will now be recorded.
Okay guys, I'm back. So to deploy an application, okay, so here when we talk about Kubernetes, obviously 90% it will be microservices. So multiple microservices will be there to have one single application. So in our scenario is, you say 15 microservices. Okay, so this is for one of the microservice, because for each microservice in the source code management, it will be 15 repos will be there. Okay, so each microservice is having separate repo, and developers whenever they do code check-in, based upon that, it will create an artifactory and it will build a Docker image in the CI job, and it will go and store in the artifactory. Then in the CD job, we take that image and will deploy. So like that, all the 15 microservices should be deployed. So depend upon each microservice requirement, we are going to configure the Helm chart. Means whatever the files are required, we'll keep those files inside the Helm chart, whether it's a config map, secrets, HPA, okay, service, deployment. These are some basic compulsory. Apart from that, many things are required, like if it is volume is required, persistent volume claim is required, then we will create pvc.yaml file. Okay, so this way we'll have microservices will be configured, and in the cd job it's very simple, only to deploy. So this Helm chart will be deployed into the cluster. So this will be deployed. So again, the cd job is also going to be executed from Jenkins. So in this job, we'll just execute helm install helm upgrade command, and by using the Helm chart location. Okay, so this way we need to do that. So to do this job, your Jenkins server should also configure with Helm. So here you are installing Git, Maven, Docker, and Helm also should be installed because to execute Helm command. And we need to copy this config file, cluster config file inside the Jenkins server. And we need to make it ready, this Jenkins server, to deploy the applications from here to here. So to do all these things, we need to configure Jenkins. So in this today's session, we will configure Jenkins. If time permits, we'll complete it, or else tomorrow we'll continue to configure this Jenkins server, right? So after configuring this, we are going to deploy the applications inside this cluster. So we have CI job with us and we have CD job. How I have an Java Spring Boot application. So I will show you how to configure that and how we do CI, continuous integration, and then how we can deploy that image with that image. So here for Artifactory, I'm going to use Docker Hub only. Okay, so I'm going to deploy these applications inside this Kubernetes cluster. Understood, right? So now first I need to make sure Jenkins is ready. So I need to create Jenkins. I have a documentation for this, and if you see here, the first one is Jenkins installation. And Jenkins installation, in the Jenkins server setup document, we have a uh, Maven, Git, Docker. Okay, these three I'm going to configure it. And after this, uh, Helm tiller configuration. So on Jenkins server, how I'm going to configure Helm, I'm going to show you. Okay, these three things are required. First of all, I need to install the Jenkins, create virtual machine, install Jenkins, and then install Git, Maven, Docker, and after that, I'm going to install configure Helm. Okay, so that this Jenkins will be ready now. So let me go to my AWS. Okay, so now I don't want these two servers. Let me delete them. So I'm going to take fresh server. Now, first Jenkins server installation. Let me see. So here take any 7 version, and prerequisites is Java compulsory because Jenkins is a Java application. So Java software should be available. And then actually I did not mention here the Spring Boot application which I am taking here in the example. There will be test cases will be available inside that software. I hope you guys are aware about test cases. Means when developers write the code, they'll write the test cases also. So when the Jenkins job execute the CI job, it will do the task of the test cases whatever has been written by the developers. So at that time, Jenkins need more resources. If your Jenkins doesn't have more resources, then those test cases will not complete on time, or it will take lot of time to take that. If your Jenkins server has enough resources, then whatever the test cases has been written by the developers, it will complete quickly. So for our application also, we need at least 2 GB of RAM. Okay, because the Java application which I'm using as a sample application, it's a Spring Boot application. So a lot of test cases are there. It need lot of memory. So that's why I cannot use T2.micro. So we need at least a 2 GB RAM. Okay, that I did not mention here. Actually, I should mention the prerequisite also. Take another type of instance. So this is how to install Java and how to configure home path and how to install Jenkins and then start the service. Okay, so let me do this. Let me create one server launch instance before this. If you see here for this t2.small is required because it's having 2 GB of RAM. So instant that machine I created for the previous batch running. So launch instance, I'm selecting Amazon Linux here t2.micro, sorry t2.small, so that I can get 2 GB of RAM. Configure, and here no need to change anything. Add storage, add tags, name cube patch Jenkins.
How much is charged for the server?
Charge we need to check in the calculator. S3 calculator will be there right in the AWS, so we
Yeah.
need to check. I never checked that.
Okay. Okay, Brian.
Maybe whenever we practice and immediately we need to shut it down. Again, when we are doing practice, power it on. Just maybe 10 to 20 rupees they'll charge, I think so. So Jenkins obviously will use 8080 port number, so I should allow 8080. Review and launch. Okay, instance is launched.
Did you use an existing key, right?
Yes.
Okay.
So this is the instance has been created. Take it and now I'll install Jenkins inside this machine. So the first thing, the prerequisite is install the Java. Okay, so I'm going to install the Java. By default, Java 7 will be there. So we want Java 1.8 version minimum. In Jenkins, you need to configure environment variable, and also you need to configure inside the global tool configuration, the Java path. Otherwise, it cannot, whenever you trigger any job, it cannot able to recognize the command. So Java hyphen version. So yum remove Java 1.7 Yes. Even though we install 1.8, still it is showing 1.7. So I deleted it. Now it is showing 1.8 version. Fine. And then we need to find the Java home and then need to configure inside the root profile. So we can execute this find command. So usr lib jvm is the location of the Java home. We are finding the path, the full path, so that we can configure it inside the Java home. So now let me search it. So this is the path. Always remember, once you go inside this one, you can able to see these directories. Okay. Sometimes you can see only this directory. JDK should be available. JDK, this belongs to JDK and this is JRE. So to run Maven integration, so JDK is also mandatory. Otherwise, Maven build, these commands will not work if the JDK is not available. Okay, so better to cross check whenever you are installing Java in Jenkins. So make sure JDK is also available. So this path I need to configure inside the roots profile. So let me go to the profile vi dot bash underscore profile. This file will be available inside the home directory of root, and here we can give java underscore home equal to the path. This is the path. Okay, and the same thing we need to mention inside the path also. Java underscore home export java underscore home. So if you mention inside the profile file, then it will be permanent. On fly also we can do that command line, but it is not permanent. It will be permanent only if you mention inside the profile file. So this way we can able to configure, and you can execute this command so that this will apply on fly. Means basically when the user logs in, it will read the profile and he logs in. But we changed the profile now. We did modification, but existing connection, whatever is established, the shell, it doesn't know whatever the changes has been done to the profile. So you need to log out and log in. So again, while logging in, it will take the latest profile file. But instead of doing that, you can able to execute this command. So it will refresh, reload the latest profile. Okay, you don't need to log out and log in. Now we can install Jenkins, and this is the way we can install Jenkins. By default in AWS machine we'll have wget command. In Red Hat Linux we don't have wget, so you can install wget. So for me already wget is available. So what we are doing, wget means through web we are getting some file. So in the web we are having, this is the file https. In the Jenkins URL we'll have a repository. So I hope you guys are aware about this one. By default, if I type, let's say, if I type this command yum install -y, it's not available. Why? Why it is not available? When I'm typing yum install Jenkins, what it is trying to do?
It will go and search in the M repository.
Yeah.
Yeah. So by default, whichever OS you take, right now I took AWS OS, and if you take Red Hat Linux, CentOS Linux, by default the OS is going to provide you some repos for you. You go inside this repos, they are providing some repositories which contains, this repo contains some URLs. So whenever you type yum install some package name, it will go and check in the URL of this repo. So if you see, this is the main.repo. Here some URLs are there. So in this URL, the packages will be available. When we type yum install any package name, it will connect to this repo and it will go and contact that internet, through internet it will connect to this URLs, and from there it will check whether the package is available or not. If it is available, it will install. OS related software you can get it here, but Jenkins is another third party software. So your OS vendor is not providing you Jenkins software in their repository. So for that purpose, what we need to do, Jenkins is providing a repo. So that repo should be available inside this path here, so that when you type yum install Jenkins, then it will go and check in that particular repo, and then it will contact the Jenkins repository into the internet, and from there it will install the Jenkins package. So for that purpose, this is a command. So from internet, we are downloading this file and copying inside this location. This command will do that task. So it is downloading this file and putting inside this jenkins.repo. So let me do that.
So M only searches
Now,
inside your machine, not going out and checking for the repository.
no, it will not go outside. Whatever the default repositories are available under this present location, it will check here.
So from internet, we need to copy to that repository so that we can use the yum later.
Yeah.
Okay.
So now when I type yum install, then it will come and check in the Jenkins repository here.
Okay.
But
So if you
Praveen,
see
if you
this
do
repo
if
now,
you do yum hello Praveen, if you do yum install updates, means it will go outside, right?
yum install, no,
Updates.
everything it will check. See, first it will contact the repo. In the repo, there will be URLs will be there. Then it will go and contact that URL to get the packages.
Oh, okay.
When you're typing yum any package name or yum update, whatever you're typing, it will come and check in this repos. So it will contact this repos, and if any update packages are available, then it will go and connect to that URLs, and from there it will pull the latest softwares. Directly it will not go to the URLs. How come it knows the URL? Those URLs are available inside the repos. So right now
Yeah.
this jenkins.repo file is also copied here, and if you see, this is a URL. Here it contains the Jenkins software. So when I type yum install now, then it will connect to this URL, and from there it will download. So now after this, import the key. Now we can use yum install. Now it can connect and it can able to.
Praveen, what is this key?
This key is for Jenkins to work. From here,
Okay.
in the same path, we are downloading this key so that Jenkins can able to work.
It's a standard one
Now,
across the internet, right?
yes.
Okay.
So now we can start service Jenkins status. It's in stop state. Start it and make sure it is permanently on. on the run level 3 and 5. So done. Now it is fine. So now we need to access it by its IP with 880 port number. So let me go and take the public IP of this machine and
Need to get the password.
so copy the password from this location.
Cat. Okay.
So this is the password. So the why Jenkins is famous, because it supports lots of plugins. That's the reason. Even though we have many tools, most of the companies use Jenkins because it have lot of plugin support. So here it is suggesting, do we want to install plugins which we are selected, or they are going to suggest some plugins, default plugins, you want to go with that. So as of now, I'm not interested to select by myself to install the plugins. Let it go by suggested plugins. So when we select this, some default plugins get installed. See, for every Jenkins version, they will add new plugin inside the installation process. Previously, they were installing only few default plugins, but every time they having new version, they need to have a, they are adding one more plugin extra, like few plugins they're adding inside this installation procedure. Very quickly it's completed. It is asking to create any user account. So I'm going to create admin, or maybe I'm going to create with my name. So give some information. So this is the URL to access this Jenkins. Yes, save and finish. So start using Jenkins.